E, calculate Kp at 100 degrees Celsius. Assume that delta HF and delta SF remain constant at this temperature. So, right, so this is then a problem where we can just, keep our lives a little bit simpler. So if we go back here, right, we already calculated the delta G of the reaction. Right, so we know that delta G of the reaction is equal to negative 70 kilojoules, right, is what we calculated earlier in that case. And so, what we can just simply do is, again, just simply use the reaction or the equation that we have, right, where we have delta G of the reaction, is equal to negative RT ln K in this case. So the only thing now that's different, right, is just the temperature is now 100 degrees Celsius, right? So 373 Kelvin. So we take all of that, right? We rearrange it. So I did that, I think, here already, right, for part B. So what we have is K is equal to negative delta G over RT. In that regard. And so, so if I plug in the values, right, we have E negative 70,000 joules, right? So I'm making sure that everything's in the same scale, divided by 8.314 joules per Kelvin. And then the temperature now is 373 Kelvin. And so what you should get is negative 70,000, 8.314 times 373. And so I got 22.57. So if I do e to the power of that, what I get is something slightly different. But here, let me just double check. $68.2. I'm getting different values for some reason. Am I doing, is something off? That's right. I would say that you can't use the delta G of the reaction, the delta G not of the reaction, right? In this case, right, you have to do the delta HF, delta S stuff. Thinking about it, right? Because that shouldn't stay the same as you go to a higher temperature, right? Because that's going to affect it, right? So what we need to do is we need to calculate the delta HF in this case. And so if we go to the back, I'm just going to do this quickly. Because I've spent far too much time, I think, on this problem. So NO2, right, delta HF is 34 times 2 minus 90 times 2, negative 112 kilojoules, right? Delta S is equal to what is it? 52 times 2 minus 87. No, not 52. 240. 240 times 2 minus 211 times 2 comes out to 58 joules per Kelvin, right? And so then if we use the equation, natural log of K is equal to, what is it? Negative delta H over R 1 over T plus delta S over R, right? We can plug in, so we have negative negative 112,000 joules over 8.314 joules per Kelvin times 1 over 373 Kelvin plus 58 joules per Kelvin over 8.314 joules per Kelvin. Joules cancel, Kelvins cancel, joules per Kelvin cancels, joules per Kelvin cancels. Natural log of K is equal to negative 112,000 divided by 8.314 divided by 373. So you get negative 36.12 plus 58 divided by 8.314, which is 6.98. Put those two together, you get negative 36.12 plus 6.98. So you get negative 29.14. Oh, wait, no. There's still a negative right in front of that. So this should be 36.12 plus 6.98. It's 43.1 in that case. And so then you just simply do K is equal to e to the power of 43.1. And so that should come out to why is this a different value? What am I messing up here? Negative 112,000. 8.314 times 373. Because I did the math again the other day. So this shouldn't be. What am I getting that's different from what I did the other day? Oh, my delta S is off. Because I forgot to include the oxygen one. So it's not 58. Oh, that's frustrating. But that will be a very common mistake that people will probably make. So FYI, that's a thing to pay attention to. Right? So delta S is 240 times 2 minus 2 times 211 plus, and now for oxygen, S is, where's oxygen? 205. So that comes out to negative 147 joules per Kelvin. So that's negative 147 joules per Kelvin there, right? So those still cancel out. So the natural log of K is equal to negative 112,000 divided by 8.314 times 373. That's still 36.12 plus, right now we have negative 147 divided by 8.314, which is negative 17.68, which comes out to being 36.12 minus 17.68, 18.44. So then that means K is equal to e to the power of 18.44, which is 1, 2, 3, 4, 5, 6, 7, 8. 1.02 times 10 to the 8th, which is what I have right there. So yeah, so that's a very important thing to think about in those regards, right? Is that one, when calculating the K's stuff at different temperatures, right? You can't just simply straight up use the delta G value because that changes with the temperature. So you're going to have to do the delta H of formation, the delta S of formation information to get that stuff. The next thing is, right, when you're doing the delta S of formation, make sure that you also include the things that are elemental in those regards, right? So don't really try and skip steps in those cases, right? Always write everything out the way that I was doing it in previous problems. Hopefully then that way you'll avoid some of the downfalls that, I came across in this case right here. So that took a lot longer than I wanted it to talk about this problem, but let's keep moving.